Let's have a look at part C in this video. So we have to perform the ANOVA test for the significance of model 2, and we have to state the hypothesis, the test distribution, the test value, and give a conclusion. So we're going to ANOVA on model 2. Now what are we trying to do here? Because we have the variation of the regression and the variation of the residual. Now ANOVA is a test where we take the relative variation, the ratio of the variation explained by the regression to the variation of the residuals, and the variation of the residuals by definition is something that we cannot explain. So in simple words, we're trying to see whether we explain more than we do not explain. So if we explain more of the results than we do not explain, means that our model, our independent variables, make sense. They have an effect on the value that we're trying to estimate, on the baby weight. So if we want to write this down in hypothesis format, that would mean that we're testing whether we have no effect of our model, no effect of our variables. So the coefficients, if we call them beta 1, beta 2, beta 3, and beta 4, we're testing whether all of them are 0 or not. And when we say that not all of them are 0, it's enough for us to have at least one of them significant. At least one of them is significant, is not 0. It's either positive or negative, because if at least one of them is significant, it means it makes sense to include all our values in the model to have these independent variables. So how do we do that? We do that with an F-test, and we said that with an F-test we need to take the ratios. We need to take the ratios of the average variation explained by the model. So the average, the mean, sum of squared differences explained by the regression, relative to the mean sum of squared differences of the error, of the residuals, unexplained by the model. What is MSR and MSE now? Well, because they're average, we're gonna take the total sum of squared explained by the model, explained by the regression, which is 29.248. So the sum of squared differences of the regression, but we have to average it. We have to normalize it by the number of parameters. So the degrees of freedom over here is going to be the number of parameters. The parameters are the independent variable in the model, so are these 4, meaning the degrees of freedom over here are gonna be 4. So divided by the number of parameters, and the average sum of squared differences unexplained by the model of the error term is the sum of squared of the residuals relative to the degrees of freedom, which are the remaining, n minus p minus 1. And we're gonna work out the math now. So n minus p minus 1, what is that? That's 715, the number of observations. Let me change colors, this is not good. 715 minus the number of parameters, we said it's 4 minus 1, so it's 715 minus 5 equals to 710. That's going to be the degrees of freedom over here. So let's plot these values and compute the F statistic. The sum of squared of the regression, that's equal to 29.248. 29.248 divided by 4. All of that divided by the sum of squared of the residuals, sum of squared differences of the residual. So that's 144.96 divided by 710. If we do the test and we get the result, that's going to be equal to 35.8. Now before we look at the conclusion, before we have the result, let's just work out with the intuition like what it means. Just let's literally write this again in terms of the formula. That's MSR divided by MSE equals to 35.8, meaning that we have an average variation that is explained by the regression is 35.8 times higher than what is not explained from the regression. Let's just do that real quick in cross product. That means that MSR is equal to 35.8 times MSE, which means that the average variation explained by the regression, explained by regression is 35.8 times higher than variation unexplained by the regression, unexplained by regression, meaning that our variables make sense, like intuitively it makes sense because they explain so much more than the error term, than the specific factors that we cannot observe. And if we have a look at the p-value of the test, which is all the way over here, so the significance of this f statistic in the second model, 0.000. What does that mean? That means that the probability of having such a high f value, such a value of 35.8, happening by chance is 0%. So it most likely did not happen by chance, meaning that indeed we have a significant effect of all these variables taken together. So in conclusion, we reject the null hypothesis, meaning that we have a joint significant effect of the four variables taken together. So of the four variables taken together. And that's it. Hope this makes sense, and we are done.